and this one when
Mm-hmm.
it is found,
Mm-hmm.
it is again hydrolyzed. It forms
Mm-hmm.
2HSO4 minus 2H plus H2O.
Okay. Mm-hmm. Okay, very good. So that is what three method basically we study
This is only so
from
this is a barium
the.
peroxide and so this barium peroxide and this peroxide disulfate are mostly the processes that are used for the less amount of production. So for laboratory production of D2O2, they are using K2H2OH and they are
Mm-hmm.
adding that with heavy water D2O. So it is
Mm-hmm.
forming so KDSO4 and D2O2. So that is the heavy deuterium peroxide.
Okay,
Sir,
thank you. Mm-hmm.
usually it is prepared by the auto oxidation of two alkyl anthraquinone. So they oxidize the two alkyl anthraquinone, it forms the anthraquinone.
Mm. Okay, great, great. Okay, here you see heavy water. Okay, what is the heavy water? Oxide of heavy hydrogen. Oxide, oxide, no, oxide, wait. Oxide of heavy hydrogen. See, heavy hydrogen means the deuterium. So it is the oxide of deuterium. Okay. So this is oxide of deuterium is called what we are calling that is heavy water. Okay, heavy water. Normal water formula is H2O, but the formula of deuterium is D. You are replacing, so it will give D2O. This formula is what is called the heavy water. This is the heavy water. Now, if you see here, it is extensively used as a moderator in nuclear reactor and is exchange reaction for the study of the reaction mechanism. So first of all, they are starting from the use only. So where they are being used as a moderator. Moderator means to slow down the nuclear reactor or nuclear reaction, whatever they are. Okay, this is. So first one is to slow down the nuclear reactor. Second one, to study the reaction mechanism. It is the use as a tracer in the study of reaction mechanism. You know, this is being used. It can be prepared by exhaustive electrolysis of water as a byproduct in some fertilizer industries. So, or, here is the word or. So, how you are preparing? The first one is the electrolysis of water. Electrolysis of water. What type of electrolysis of water? What type of electrolysis? Exhaustive electrolysis. Exhaustive. What do you mean by exhaustive electrolysis? That is long time. You are using the long time. If you are doing the long time electrolysis of water, what you are going to get? You are going to get the D2O, heavy water. Now, another thing is there as a byproduct in some fertilizer industry. So when your fertilizer is being prepared, there is the as a byproduct also possible. Its physical properties are shown in table 9.3. It is used for the preparation of other deuterium compound. What are the compounds it is being used? Now the first one. This is called calcium carbide. If you are heating with the heavy water, it will give the C2D2. And another is calcium deuterohydroxide. This is what is called calcium deuteroxide. Earlier it was calcium hydroxide. It is nothing is there. Calcium OH whole twice are there. This is converted into CaOD twice. If you are treating with SO3D2O, so it will give what? Deuterosulfate, D2SO4. Like SO3 is there. If you are treating with the H2O, it was giving H2SO4, hydrogen sulfate. So if you are treating SO3 plus D2O, so it is going to be D2SO4, deuterosulfate. Similarly, if you see aluminum carbide is there, you are treating with the heavy water, it will give CD4, just like methane, and ALOD thrice. These are the chemical properties. Are you listening or not? No
Sir,
sound?
listening actually, sir, my mic was off, sir. That is why I couldn't.
Okay, now come here in the next slides. Here the Urey was the person who discovered this one. What is the name? Urey discovered the heavy water. Urey, he was discovered. Who prepared this one? Lewis and Donald were the person who discovered. No need to this one study. This one you can study. Taylor's. This was the electrolytic procedure. So no need to study the name. Okay, that will not come in the exam. Okay. Now, mostly it will come from the NCERT. See, almost all physical properties like melting point, boiling point, density higher than the water because mass of deuterium is greater than the hydrogen. It is injurious to living organism. So every properties are what they are saying. Every properties are greater than what? Hydrogen. Normal hydrogen, if you study, it is the properties are the high, like melting point, boiling point, density, everything. See here, the table you see. What you are going to observe, this one. Can you check here? The molecular mass 18 and here is 20. If the molecular mass increases, so what it is increase, Sanoy? If the molecular mass increases, what is happen? Intermolecular force of attraction also increases. Getting my point? If molecular mass increases, intermolecular force of attraction increases, right? So here what will happen? See the boiling point. See the boiling point. 273 are there. Here is greater. Yes or no? Melting point was there. Boiling point 373, 374. Enthalpy of formation minus 285, minus 294. 40 point enthalpy of vaporization 40, here is 41. Enthalpy of fusion is not there. Temperature density 276, 284. So what you are observing, every property are more than what the H2O. Yes or no? Why?
Yes.
Because its mass is higher. I hope it is clear to you.
Yes.
So here they are saying density is higher than H2O because mass of deuterium is greater than the hydrogen, right? No.
Yes.
Chemical properties. We are going to study the chemical properties. What are the chemical properties? Okay. So chemical properties, NCERT level we already mentioned here. We are going to deal with the other one, right? So if you see other chemical properties, what you are finding? There are many more chemical properties. Logically, they can ask, right? Logically. So H2, D2O is there, na? D2O. So what will happen? OH is exchange. OH is exchange in the glucose if you are treating with. Glucose will exchange. Suppose the glucose formula is what there? CHO. Then CHOH 4 times. CH2OH. So what the formula you are resulting formula? Can you tell me? Resulting formula CHO is there. CHOD. How many times? 4 times. What will be there? CH2OD. Not getting?
Sir, getting it.
Okay. See, if you are treating with the H2O2, so it will give D2O2. What reactions are there? Exchange reaction. So this one, NH4, if you are treating with NH4, so ND4, it will give ND4 plus. Acetate is there, CH3COOH. So it will give the exchange reaction. How it will give? CH3COOD. This is exchange reaction. At the place of H, it will come D. Okay.
Sir, but here H is not there.
But negative charge is there, na negative charge.
Negative charge.
If you are ionizing again, it will give now CH3 COO minus plus D plus. This is like that. Acetylene, if you are treating with acetylene, exchange both hydrogen and alkaline medium. So both hydrogen is what they are saying. Acetylene exchange both hydrogen. Both hydrogen, if suppose acetylene we are having CH triple bond CH. So if you are treating with the D2O, both the hydrogen will be replaced. CD triple bond CD. Just it is not going to come, generally it will not come in your exam, but it is the logical, na? Logical. So just to tell the logic I am telling. Now see, if you are treating the, see here, if you are having H2O, treating with the Na. So what it will give? NaOH. Plus which gas will liberate? Hydrogen gas. Take the two molecule. Total hydrogen is 4, oxygen is 2. So what if you are treating with the metal with the water, it gives the hydrogen gas. But if you are treating metal with the heavy water, what it is going to give?
Metal with heavy water, so that will give.
Little bit mistake. I think they have given D2O. Here it cannot be oxygen. How can be oxygen? D2O plus sodium. So what will give? 2 NaOD plus what will come? D2. A little bit mistake is there. D2 gas. Heavy hydrogen. Oxygen. Yes. Next one. If you are treating with the Na2OD, it will give the NaOD. Here is the calcium carbide, CaOD twice, C2O2. So this we have already in NCERT we have done. See, if you are treating with the aluminum carbide, this we already done in the NCERT. Aluminum carbide, if you are,
this will be Mg3N2. So this will be AlCl3.
Some mistakes are there. Here, this way we have done NCERT. So like that, if it is coming, you can be able to answer this one. There is no problem in that. Okay. Here you see hydrogen economy. Hydrogen economy. What do you mean by hydrogen economy? You must be knowing. In your school, this chapter taught? No.
No.
Okay. What do you mean by hydrogen economy?
Sir, they are using the hydrogen as fuel in various places.
That is what the hydrogen economy. Because all the fuel, whatever the source we are using, nowadays they all are producing huge amount of what? Pollution. And the secondly, that is the one more problem is there. What is the problem? They are all getting depleted because coal we are using in power plant, all the coal are getting decreased. It is not getting increased. So coal is depleting. Some other source, what petroleum are there, they are also getting depleted. So it is not being used for the, not is being safe for the future generation. So what that is, hydrogen can be used as a fuel. Okay, that is what is the use of hydrogen as a fuel is called hydrogen economy. So here you see what the term they have given, hydrogen economy. What is the hydrogen economy if you talk about? So hydrogen economy means use of hydrogen as a fuel. This is what the hydrogen economy. Getting? Okay. On the board it is, I don't know what is coming here. See, it is not going out. Okay. Hydrogen could replace coal, oil, major source of energy. The hydrogen fuel is environmental friendly. The problems to overcome are production of H2 at low cost. This is the problem. Problem to overcome are That is, you cannot produce H2 at low cost. H2 is costly. Like that, major source is water is there, na, H2O, source of hydrogen. And it required to produce that one, electricity is required, electricity. Okay, electrolysis. This is the only industrial process, H2 plus O2. So this is difficult because again electricity is being used. The solar energy can be used, but it is depend upon the environmental catalyst. So solar energy also required what? The depends on the development of the catalyst. Okay, without catalyst we cannot use. Strong storage and transportation. It is the storage. Now you see, it is the lightest gas. Hydrogen is lightest gas. So to store this one, huge volume of the container required, na? Big volume, big container required. So if you are using the bike, suppose you are using the bike, so your tank will be bigger than the bike. That is why its storage is problem. Transportation is also problem. Why transportation? If any point of time it is mixing with the oxygen, it will blast. That is why. Okay, that is why it is very difficult to use these things. Getting my point? No.
Yes, sir.
So hydrogen economy is there. That is, I think it is almost over, Sanoy. This chapter is little bit. We are going back to the NCERT. It is this all the things. Give me 1 minute. Let me erase this one. If any point are there in the NCERT which we can deal, that we have to study. Okay. Here, because NCERT lines we cannot miss. That is why I am dealing this one. Dihydrogen as a fuel. Here you see, this is dihydrogen as a fuel. What they are saying, dihydrogen releases large quantity of heat on combustion. How much? Large quantity. 1 gram hydrogen. 1 gram hydrogen. Highest something 286 kilojoule. 286 kilojoule. And this is the highest. You know. So it produces the highest energy. Highest energy. Okay. How can you say that highest energy? You see, come back here. See, energy released on the combustion of 1 kilojoule in a state. So now you see the dihydrogen are there in a gaseous state and dihydrogen liquid state. You see per gram. Per gram. If you see per gram, how much is there? 146 and 142. Gaseous state 143 and liquid state 142. But in comparison to other, you see LPG, how much? 50, very less. Methane, 53, very less. Octane, very less. Can you see? So means it produces how many times? 3 times. Almost 3 times heat. 3 times energy. Energy than fuel. Yes or no?
Yes.
So that it is being used as fuel because it producing the huge amount of what? Energy. But you be careful. Per mole it is less. Per mole it is going to be less, very less.
Per mole is less, per liter also it is very, very less.
That is it. Per gram we are talking, per gram it is highest. Per mole it is less. Now, you come back here, the same one, come on the top. Here. So first point is over. Now, the data of energy released by the combustion of fuel like hydrogen, methane, LPG are compared in the terms of the same that we study. So amount of mole volume are shown. From the table, it is clear for the mass basis, hydrogen can be released more energy than petrol. What basis? Mass basis. Always keep in mind. Otherwise, if you are putting the any of the option in the mole case or any other case, that will be the wrong. Always you need to see the in what reference it is the highest, right? Now, how many times? About how many times? 3 times. This is next point. Moreover, pollutants in combustion of the dihydrogen will be less than petrol. no pollutants. Getting because if you are burning the H2 and O2, so what it
Oxidation of
will give?
hydrogen, oxygen gives water.
Water give. But in case of the if there is the hydrogen is having little bit nitrogen, so it will release the N2O or NO2. The oxide of nitrogen will can also release, but if it is the impure, the only pollutants will be the oxide of dinitrogen due to the presence of nitrogen as impurities with dihydrogen. So if there is a impure hydrogen are there, so only one pollutant is possible. What is this pollutant? What is this pollutant? Tell me.
So this
What?
NO2.
This is the oxide of dinitrogen. Next one. This, of course, can be minimized by injecting a small amount of water into the cylinder to lower the temperature so that reaction between the dinitrogen and oxygen not takes place. So we can minimize this, what the pollution is being formed, that we can minimize. How can we minimize? By lowering injecting the small amount of water into the cylinder to lower the temperature so that the reaction between nitrogen and dioxygen not takes place. Because to react the N2 plus O2, okay, something at 1200 Kelvin and heat required. So if your temperature is lower, this gas will not form, N2 will not form. So this question can ask, how can you minimize? So by lowering the temperature. However, the mass of the container in which the dihydrogen will be kept must be taken into the consideration. What the point see? However, the mass of the containers in which dihydrogen will be kept must be taken into consideration. A cylinder of the compressed dihydrogen weight about 30 times as much as the tank of petrol containing the same amount of energy. What do you mean by this? The mass of cylinder, whatever you are using now, if suppose bike you are having, petrol bike is there. Okay. So if suppose it is the 30 kg. So in case of hydrogen bike, in case of hydrogen bike, can you tell me how many kg tank you required? 900.
The 900.
900 kg tank. Why? Because H2 and O2 are highly inflammable. They catch the fire and the tank will blast. That is why. Also, dihydrogen gas is converted into liquid state cooling to 20 K. So at what temperature dihydrogen is converted into liquid state? Can you tell me? It is the cooling up to 20 K below room temperature. Okay, not below room temperature, it is so less. Okay, because you see here, 273 is equal to 0 degree. Yes or no? So 273 is equal to 0 degree. So 1 K is equal to how much there? 0 degree C by 273. So here how much there? 20 Kelvin. No, 20 Kelvin. So 0 degree C upon 273, 20 Kelvin. So this Kelvin cancel out. So you will find that is it will come almost very negative. In the degree C, it will be negative. Yes or no?
Sir, minus 253.
Minus 253. So how can you degree C? How can you cool this much of temperature? That is the problem. Okay. This would require expensive. See the question, what they are saying. Sorry. Insulated. What point? Insulated tank. This would require insulated tank. What type of tank? Insulated tank. Tank of metal alloy like NaNi5, TiTiH2, MgMgH2, etc. are used for the storage of dihydrogen in a small quantity. These limitations have, what happened? These limitations have promoted researchers to search for the alternative technique to use the dihydrogen in an efficient way. Hydrogen economy, few lines are there, that also. In this view, hydrogen economy is an alternative. This basis principle of the hydrogen economy is the transportation and usage of energy in the form of liquid or the gases. dihydrogen. Advantage of hydrogen economy is that energy is transmitted in the form of the dihydrogen, not as electric power. It is for the first time in the history of India that the pilot project using dihydrogen fuel was what they did, launched in October 2005. That you need to keep in mind what are the possibilities. For running automobile, initially 5% dihydrogen has been mixed in CNG, used four-wheeler vehicle. How many percentage? 5% dihydrogen is being used. Which year pilot project launched? 2005. The percentage dihydrogen would be gradually increased to reach the optimum level. Last one, see, nowadays it is used in a fuel cell for the generation of electric power. It is expected that economically viable and safe source of dihydrogen will be identified in years to come for usage of common source of energy. So that is what this chapter is finished. This chapter is over. You can study some the problem. The element which is biggest source of energy in future is, can you tell me? Which can be the answer?
One second, just.
Check. Just run your mind.
D or D? So D,
D will be there. Now, lightest is what? Lightest. Which one is the lightest? Lightest is what? This is the lightest is what? The hydrogen, na? So the hydrogen gas will be used. 1 minute, Sonu.
Yes.
क्या तो पढ़ा रहे हैं बकवास कर रही हो
আমি তো টিচার হলো তো বার করে দিতে হবে ঠিক আছে মেডিসিন খাচ্ছি হয়ে যাচ্ছে 4 দিন ধরে
What is the second one? Second one. Dinitrogen is liberated at
acidified water.
Acidified dinitrogen is liberated at the anode. Very good, very good. Next.
Sir, this one I'm being a bit confused whether this should be endothermic or exothermic.
Third one, the conversion of atomic hydrogen to dinitrogen. Atomic hydrogen. So bond formation is, what is the bond formation? Indo or exo? Bond formation. Bond formation is Indo or exo? That you tell me.
Bond formation is
bond
formation is
bond formation is exo, na? Exothermic. Exothermic. So here is the, what is the hydrogen? What is there? Conversion of atomic hydrogen. 2 hydrogen atom is there. It is converting into hydrogen gas. It is converting into hydrogen gas. So what will be there? Energy released. Because bond breaking, bond dissociation energy you need to supply. And if the bond is formed, it is the energy will automatically formed. Getting or not?
Yes, sir. So then the answer will be this one. Exothermic.
Next one. Next you study. Are you telling the answer? This time you need to score more marks in the what subject? What I am supposed to tell? Chemistry, then physics. Because only you are getting the marks in physics and bio, not the chemistry. Yes or no?
Sir, bio and physics also this time it was less one. I got only 40.
Okay. Now you see, tell me this one. Which option you are telling? Question number 4.
Sir, this will be deuterium.
Deuterium or tritium?
Deuterium will.
No, tritium. Tritium. It will be tritium. Tritium is radioactive now. See here. Wait. This is NCERT now. Give me the time. Let me find out the. Somewhere there is
Sir, I
isotope.
checked just now. So tritium mostly is the answer.
Tritium is the answer or not the answer?
Yes, sir. T half equal to 12.50 years.
Where did you find this one? We need to isotope. Yeah. Read this one and find out the answer. Is there? Protium has no neutron. This is okay. URIP Nobel Prize. That is okay. Where is the half-life period? Yeah. What is there? Of these isotope, only tritium is radioactive and emits low energy beta particle. T half is how much? 12.33 years. Which is the option?
Sir, C.
Then which one you are telling?
C. Tritium.
Okay. Next one. Next one you see. Zinc on reaction with KOH. Liberate combustible gas. Dilute HCl. Very good. Very good. What about the H2SO4? What about KOH? Which gas will be coming? Option will be D. Option will be D. Whether metal react with acid or the base or some other things, the gas will be always which gas?
Hydrogen gas.
Hydrogen gas.
Sir, here HCl, sir, it will give only hydrogen, whereas here it will give also oxygen will also be given. Sulfur is given.
But the hydrogen is also liberating now. Where is the? I am searching the file, but I'm not getting where I kept the file. Okay, you find out. Next one. Which next one? Hydrogen gas can be produced from water gas, producer gas, coal gas, or air. Okay, match the answer first of all. Match the answer. Okay, first one option they have given D. Which one you are telling? You are telling B, but the correct option is D. Second question A. Molten sodium hydride. Hydrogen is liberated at the anode by electrolysis of molten sodium. The here is the option they have given, Sanoy. This option they have given. Which one? Option A. Third one is C. Exothermic. That is correctly you say. Third one. Fourth one is C. The fourth one is C. That is also correct. Fifth one is D. So all the cases hydrogen will be reproduced. Okay. Now 6 you are telling hydrogen gas will produce from which one option? You tell the option. Hydrogen gas. About the hydrogen gas. Have you studied the water gas? Because water gas is what? Combination of what? That is hydrogen.
Yes.
No. So this will be the water gas. Very good. Okay, something is you are very good. Next one. Water gas is correct. When zinc is dropped into NaOH solution, H2 is obtained. and soluble is obtained. So which one is salt is you are going to get? Which salt? Na2, ZnO3, NaZnO2, Na4, Na3. Which one?
So I think B will be the answer.
B is the answer only. B is the answer, not will be.
Sodium zinc.
See here, question number 8. Question number 8. Question number 8. Question number 8.
So checking.
Question number 8, you are saying PD. Fe, okay, you are saying PD. 8. 8 options C they have given. Oh, 8 options C they have given.
So can I explain this one how?
H2O. This will CO plus H2. FeGrO4. B2O5. That need to check. That needs to check. Needs to check. Because it should be interstitial catalyst. Nah, this is the catalyst. So X can be, it should be Fe also. Because interstitial hydride we can take. This one is not there in NCERT, na? So that is why the problem may be. Will be. I'll check. I'll check and I'll tell.
Okay.
Question number 9. Up to 10 we will do. Question number 9. H2 can be obtained from the mixture of CO2 H2O by bubbling the mixture through water. So option A will be there. 10 question. H2 plus A. This temperature you are using, Fe you are using. So alkaline gas is being formed. Which gas will be formed? So what will be they are asking A. So alkaline gas is NH3, basic.
NH3.
Because Fe catalyst, na, this is which one? Haber process. This is Haber process. So N2 plus, H2, 3H2 plus 2N2. Now H2 plus N2, it will give 2NH3. And temperature, you are already saying that is Fe, 2NH3. So this is, okay. So that way you need to